Deep in the southwestern Pacific, near the Solomon Islands, an unusual volcano is quietly rewriting the rules of how land is born. Known as Kavachi, it sits just below the sea surface, erupting so violently that it occasionally builds entire islands overnight, only for the Pacific to erase them days later. Sailors have watched steam towers blast into the sky from what looked like empty ocean. Scientists have shockingly discovered sharks swimming inside its crater. Most of Earth's volcanoes are underwater, unseen, and poorly understood. Kavachi is one of the rare places where that hidden world briefly breaks the surface. But what exactly is happening beneath this restless patch of ocean, and how dangerous could it become? Kavachi sits south of Vanunu Island in the island nation of Solomon Islands, within a tectonically violent region where several of Earth's major plates interact. While most volcanoes form stable mountains or long-lasting islands, Kavachi exists in a constant state of creation and destruction. Eruptions repeatedly build small islands above the sea surface, only for waves and erosion to erase them within months. Local communities of the Solomon Islands believe that powerful spirits inhabit the volcano, and for centuries, fishermen have treated the area with caution. Modern science confirms that their caution is justified. Kavachi is an extremely active geological system capable of sudden explosive eruptions, violent shockwaves, and rapidly changing seafloor landscapes. Most volcanic activity on Earth actually occurs beneath the oceans, far from human eyes. Kavachi is one of the few submarine volcanoes that erupts so frequently and so violently that its activity occasionally breaks through the surface, allowing scientists to observe the raw process of island formation in real time. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The existence of Kavachi is tied directly to the intense tectonic activity of the Solomon Islands region. This part of the Pacific sits along a complex boundary where the Pacific Plate is being forced beneath the Indo-Australian Plate in a process known as subduction. Subduction zones are among the most powerful geological environments on Earth. As one plate dives beneath another, immense pressure and heat build deep within the Earth's crust. Water trapped in the descending plate lowers the melting point of surrounding rock, generating magma that rises toward the surface. Over time, this magma feeds chains of volcanoes that stretch across ocean basins in curved lines, known as volcanic arcs. The Solomon Islands form part of such an arc. Numerous volcanoes dot the region, both on land and underwater, each connected to the same deep tectonic engine. But Kavachi is different from most of its neighbors. Instead of forming a large island volcano, it lies almost entirely beneath the sea. The summit of Kavachi is typically located just a few tens of meters below the ocean surface. Eruptions here are very different from those at land volcanoes. Because the volcano lies beneath the ocean, its magma interacts directly with seawater. This interaction produces a type of eruption known as phreatomagmatic activity, where magma and water violently collide. Observers on nearby islands have reported towering plumes of steam and ash rising hundreds of meters into the sky. The sea around the volcano often becomes discolored with floating pumice and volcanic debris. These eruptions can occur with little warning, and there are limited monitoring equipment in the region. Activity is often detected only when ships encounter floating pumice fields or when satellite imagery captures plumes rising from the ocean surface. The suddenness of these eruptions makes Kavachi particularly hazardous for vessels traveling nearby. One of the most fascinating aspects of Kavachi is its repeated creation of temporary islands. During especially strong eruptions, vast quantities of volcanic material accumulate around the summit. If the eruption continues long enough, the growing mound can eventually rise above sea level. Satellite images from past eruptions show small, dark islands appearing almost overnight. These islands often consist of loose volcanic ash, pumice, and fragmented rock. They may measure only a few hundred meters across, but they represent a remarkable geological moment, the birth of new land. Yet these islands rarely survive for long. Unlike the solid lava flows that form many volcanic islands, Kavachi's islands are composed mostly of unstable ash deposits. Ocean waves quickly erode the fragile shoreline. Storms and currents carry the volcanic material away, returning it to the seabed. Within weeks or months, the island disappears completely, leaving only open ocean above the volcano once again. One of the most surprising discoveries at Kavachi came when scientists deployed underwater cameras inside the volcanic crater. Researchers expected to find a harsh, lifeless environment. The water inside the crater can become extremely hot and acidic during eruptions, conditions that would normally be hostile to most marine life. Instead, the cameras captured something astonishing. Moving through the murky water were large sharks. Among the species observed were scalloped hammerhead sharks and silky sharks. Their presence raised immediate questions. How could large marine predators survive inside an active volcanic system? Scientists believe the sharks likely enter the crater during periods when the volcano is relatively quiet. The crater may provide a temporary refuge from predators or strong currents in the surrounding ocean. However, when eruptions resume, the sharks must quickly escape before conditions become lethal. Exactly how these animals sense volcanic activity remains unclear. They may detect subtle temperature changes, chemical signals, or vibrations in the water before eruptions occur. Whatever the explanation, their presence reveals something astonishing. Even in one of Earth's most volatile geological environments, life has found a way to exist. This discovery also transformed Kavachi into a natural laboratory for studying ecosystems that thrive in extreme environments. Although Kavachi does not threaten major population centers, submarine volcanoes pose several unique geological hazards. The most immediate danger is explosive eruption. When magma interacts with seawater, the resulting blast can generate powerful pressure waves. These underwater shock waves can travel long distances and may damage ships or underwater infrastructure. Another hazard comes from floating pumice. During eruptions, vast quantities of lightweight volcanic rock can be ejected into the sea. These rocks float for weeks or months, forming thick rafts that drift with ocean currents. Ships passing through pumice fields may experience engine failure if the rocks are sucked into cooling systems. Submarine eruptions can also release large volumes of volcanic gas, including carbon dioxide and sulfur compounds. In confined areas, these gases may temporarily alter water chemistry, potentially affecting marine ecosystems. In rare cases, submarine volcanoes can trigger small tsunamis if large portions of the seafloor collapse during eruptions. Although no major tsunami has been linked to Kavachi, the possibility cannot be entirely ruled out. Because submarine volcanoes are difficult to monitor, predicting these hazards remains a challenge. Most of the time, scientists rely on satellite imagery, passing ships, or occasional research expeditions to detect signs of activity. Now you might wonder whether Kavachi and the Pacific's other renowned submarine volcano, Axial Seamount, are similar, or if they operate in entirely different ways beneath the ocean's surface. At first glance, Kavachi and Axial Seamount could not appear more different. One erupts violently just beneath the ocean surface in the tropical Pacific, occasionally blasting steam and ash high into the air. The other lies more than 1,400 meters below the sea off the coast of Oregon, hidden in the cold darkness of the deep ocean. Yet both volcanoes offer scientists valuable insights into the mysterious world of submarine volcanism. Kavachi sits in a subduction zone where tectonic plates collide, generating explosive magma rich in gas. Axial Seamount, by contrast, forms along the Juan de Fuca Ridge, where tectonic plates are slowly pulling apart. Instead of explosive blasts, Axial typically produces effusive eruptions, where molten lava flows quietly across the seafloor. Another major difference lies in how scientists study them. Axial Seamount is one of the most heavily monitored submarine volcanoes on Earth, equipped with seafloor instruments that track earthquakes, ground deformation, and magma movement in real time. Kavachi, by comparison, remains largely unmonitored due to its remote location. This contrast highlights how little we still know about many of the ocean's most active volcanoes. Predicting the future of Kavachi is difficult. Like many submarine volcanoes, it operates on irregular cycles of activity and dormancy. Eruptions may occur multiple times in a single decade, followed by years of quiet. What is clear is that the volcano will continue its cycle of destruction and creation. As long as subduction persists, Kavachi will remain active. Future eruptions may once again produce temporary islands. Over geological timescales, however, repeated eruptions could gradually build a more permanent structure above sea level. Many volcanic islands around the world began exactly this way. Over thousands or millions of years, repeated eruptions accumulated enough solid lava to resist erosion and remain above the waves. Whether Kavachi will eventually form a lasting island remains uncertain. For now, it remains a restless volcano lurking just beneath the ocean surface.